Hello everybody and welcome to Blockchain Expert. In this video, I'll be going over transactions. Now, transactions are fundamental to understand because that's how we send money across a blockchain network or send tokens. We create a transaction, and that transaction has the information that is submitted to the blockchain network and then verified so that we can actually transfer funds. So just like with a bank, we create a transaction if we want to send funds or send tokens to someone else. So let's start going through the architecture, or I guess the composition of a transaction, the different things that actually make it up. So when we want to create a transaction on a network like Bitcoin, we need to start with a from address. So this is the address of you, whoever is going to be sending the money. Next, we have the to address. This is where you want to send it to. We then have an amount. So this will be the amount in the native token for that network. So for example, with Bitcoin, we may be sending something like 0.1 BTC. Next, we have a signature. This is also referred to as a digital signature. This actually secures the transaction and proves that you are the owner of the from account and you have the ability to send these funds. We'll talk about how that works later. We then will have something like the gas or the fee. Now, this might have a different name depending on the network that you're on, but we need to submit some form of fee or some form of gas that actually will pay the miners to allow our transaction to be added to the blockchain network. So it's not free. We do have to pay an amount. That amount depends on many different things. And then lastly, we have what's referred to as the TX hash or the transaction hash. Now, the transaction hash is simply a hash of all of this information. So we run it through a hash function, and it's a unique identifier for the transaction. So that's it. That is what makes up a transaction. Now, of course, once we submit a transaction, there will be a timestamp on that transaction as well, but we don't need to manually add the timestamp ourselves when we're doing this. Really, if you were actually to think about what you would need to do to send a transaction, at least from most modern wallets, you would just have to put in the to address, the amount, and then the amount of gas. Usually that's pre-generated for you, and then it would be able to send. It would automatically sign for you, and it would automatically generate the transaction hash, add the from address, etc. Most modern wallets do all of this for you. You wouldn't need to manually do this unless you were trying to write, for example, your own wallet program. Now, one important note here before we go any further is that the data you see here is what's a part of a Bitcoin transaction. When we're talking about an Ethereum transaction, we actually have two additional fields. So the rest of this video is going to be covering Bitcoin, but I just want to mention that when we're dealing with Ethereum, this works slightly differently. It is similar, but it's a bit different, and it contains two additional fields on an Ethereum transaction. That first field is going to be the nonce, and the second additional field is going to be the data field. Now, the nonce is simply a transaction counter. So the very first transaction you send from a specific account or from a specific address, you're going to have a nonce that's 0. Then from that same address, if you send a second transaction, the nonce is going to be 1. So it's kind of just uniquely identifying all of the transactions sent from an account. There's a reason why we have this. It has to do with some blockchain security features, but that's just one thing to note. So it's the transaction count from transactions on this specific account. Okay, that's the nonce. Next, we have our data field. Now, the data field is going to contain things like what function may be called on a smart contract. I know we haven't got to that right now, but since Ethereum supports smart contracts and development, we need to be able to submit data to the blockchain as well. So this data field is going to contain exactly that. It's going to contain maybe a smart contract itself, so the compiled code for that, or it's going to contain kind of the correct data to call a smart contract function, etc. So that's just one important nuance here. When we're talking about Ethereum, we have these two additional fields. Just be aware of that. Okay, so that is the makeup of a transaction. Fairly straightforward. Now let's start going through all of these different aspects and how we actually create it and kind of how this works. So what we would do is we would start by creating that transaction with those properties I discussed. So we need the signature, we need the from, to, amount, all of that kind of stuff. Now, once we do that, what we're going to do is submit this to something called a transaction pool. Now, we have a blockchain, right? And we're going to talk more about how blocks work and all of that and the mining algorithms in later videos. But for now, we have our blockchain. So we'll kind of put, I don't know, what do you want to call this? A box around our blockchain. Now, I guess as a part of the blockchain, we have something referred to as the transaction pool. So we can call this the TX pool. Now, the TX pool is where transactions go before they're officially added onto the blockchain. So what we would do is we'd be sending our transaction to this transaction pool with a bunch of other transactions, and then there's going to be a bunch of miners or validators on the network which are going to be reading from this transaction pool. So we can just say miner like that, or miners. Now, what these miners will do is they will take our transaction, they will verify that it is indeed correct and that we have the ability to create this transaction based on the digital signature that we'll submit alongside it. And then they're going to start assembling what's known as a block. Now, this block will contain a bunch of different transactions, not just ours, but of course ours will be a part of one of these blocks. And then once they've created a block that meets the block requirements, which we're going to talk about in a later video, they will submit that block to the blockchain where it will then get added, and all of the properties of the blockchain will then apply to our transaction, which is a part of this block. I just wanted to break down that basic architecture for you so that you have some idea of kind of how all of this works. Take the transaction, submit it to a transaction pool. Transaction is then picked up by different miners or validators on the network. They then add it to a block. Well, they try to add it to a block, essentially. Once they have a block that meets the requirements, they submit that to the blockchain network, assuming that it's all good and there's no fraudulent activity going on. It's then permanently added to the blockchain. That is why it can take a fair amount of time for your transaction to actually be completed, to be confirmed, to be added onto the network. And again, I'm going to talk more about how all of that works later on. Okay, so now that we have the basic, flow of a transaction down, we need to talk more specifically about how we create the transaction. Now, I know we said that we need from, to, amount, signature, etc., but when you create a transaction, it's a little bit more complicated than that. So specifically, we have the inputs to the transaction and the outputs to the transaction. So on our output side, we're going to have a few things. The first thing that we're going to have is the two addresses. So this is who we are actually sending money to. And then for each of those two addresses, we're going to have the amount that we want to be sending. If we want to keep this simple, we could just say the to address, so the place that we actually want to send the money to, and then the amount that we want to send. But just keep in mind, you can actually send to multiple places. Again, depends on the blockchain network, but you'll see that this is going to, at minimum, send to two places. And the reason for that is the next things that we have at our output. So after this, we're going to have our fee or our gas. So in the context of Bitcoin, this will be gas, but on other networks, it'd be some type of fee. It might be called something else. And this is how much we're submitting with the transaction that we want to be used by the miners so that they actually prioritize sending our transaction. So what I mean by that is that miners are going to look at all of the transactions in the pool, and depending on the volume of the network, they're going to be picking the transactions that have the highest transaction fee, because they're going to get that fee if they submit that transaction on a valid block. So of course, they're going to pick the ones that have the highest fee. So if we want our transaction to go faster, we'd submit a higher fee. If we don't really care, we'd submit a lower fee, but there is typically kind of a minimum fee. And if you were to submit something below that, your transaction may never actually be picked up and never sent, because there's always more transactions coming in that would have a higher fee than yours. Again, we don't need to get into that too much here, but just understand this is kind of the reward for the miners. So you want to send a sufficient fee for your transaction to actually be processed. Continuing here, we're going to have what's referred to as the change. Now, the change is how much money or how much Bitcoin is going to be returned to you. And the reason why we need that is because of the inputs to our transaction. So we have our two addresses, our amount, our fee, our gas, and our change. And right now the change makes no sense because we haven't talked about the inputs. So that's what we're going to do now. So when we're trying to make a transaction, we know what we need for the transaction. And most of it's on the output side, right? The to address, the amount, the fee, and the change. We also need a signature. However, what we need to do is we need to prove that we have enough balance in our account to be able to actually send this transaction. Now, the way that we do that is we provide other transactions as inputs to this transaction. So since our wallet starts with a balance of 0, what we need to do is pass to the transaction we're trying to create a bunch of transactions that have amounts received that sum to at least this amount plus the fee and the gas. Now, typically it will be larger than that, but it needs to be at minimum the amount plus the fee and gas that you're going to be sending, or just the amount and then the fee and the gas would be subtracted. Depends kind of how you're doing this and how the wallet software is set up. Either way, you need to submit transactions that sum up to at least how much is coming out from this transaction. So what that would be is actually just the exact transactions, right? And specifically, it would be the hashes of the transactions that you have received in your account. So maybe this transaction has 1 Bitcoin, maybe this one has 2, maybe this one has 3. So you're now feeding as inputs to this transaction a total of 6 Bitcoin, right? 6 BTC. So now that you've fed these inputs to the transaction, you're proving that you have 6 Bitcoin because all of these transactions would have been sent to you. And anyways, there you go. You're proving that you have 6 Bitcoin in the account at minimum. Now that you've done that, what you do is you list the amount, right? So in this case, maybe I want to send 5.5 BTC, and maybe there's a fee. It usually wouldn't be this high, but maybe it's 0.1 BTC. Okay, so the total amount in the output, and I guess we'll just write it up here, is going to be 5.6 BTC. So this is where the change field is going to come in. Since you are sending, or since you are providing to the transaction 6 Bitcoin and you are only sending 5.6, you need to specify that you are going to be receiving 0.4 BTC back in change. So this transaction is going to use all of this 6 Bitcoin that you fed as inputs, but since you're only sending 5.6 Bitcoin to the recipient addresses here, now what you need to do is you need to specify the change. So you specify the change of 0.4, and what happens is once this transaction goes through, money gets sent to the 2 addresses, the fee gets eaten up, and then 0.4 BTC gets returned to your input, or gets returned, to your wallet. So that is what the change field is. You've sent 6, but you've got returned 0.4, so in total, your net balance afterwards would be 0.4, assuming that you started with maybe 6 Bitcoin in the wallet. So hopefully that makes a bit of sense, but that is kind of how this works. You provide inputs, which are transactions that prove that you have balance in your account. So the value for all of these transactions, the amount that you would have received, needs to sum to at least how much you are sending out. Once you provide those inputs, you now have an amount that you're able to send. Now, you cannot send more than that amount, and if you want to send less, then you specify the change field, and then that amount is returned to you. So this keeps an entire history on the blockchain of all transactions and where funds are actually coming and going to. So it's very interesting because now all of these transactions are going to be linked to the transaction that I just sent. So from this transaction here, I can see where the money actually came from to create that specific transaction. So there's now a forever kind of log on the blockchain that gives you the entire history of every single coin or every single amount that's ever been sent. If you receive this transaction, you can see right down to the absolute origin of the Bitcoin network where these funds are actually coming from and how many different accounts and wallets that they went through before you eventually received them here. So it's very interesting. That's why you need to do that. And again, it's mostly just to prove that you have the balance. Now that we have talked about that, let's talk about digital signatures, which are your proof that you can send this transaction. All right, so now that we've talked about that, we're going to dive into digital signatures. Now, the digital signatures are what prove that you have the ability to send a transaction. So the way this works is that we have our transaction, and this transaction has a bunch of data. Now, it has our inputs, of course, and it has our outputs. Now, really, all of these are just kind of text fields, right, that we've filled in or that our wallet application has kind of completed for us. So what we do once we have this entire transaction is we take all this data, which we're going to refer to as the message. So everything here, all the inputs, all the outputs, all of the information about the transaction, we just refer to that as the message, and we run that through a hash function. So we'll just call this f of x. Now, this is going to give us the transaction hash. Now, the transaction hash will be somewhat uniform, right? It'll be a similar length, or it'll be within the bound of a specific length, etc. You don't really need to know exactly what the transaction hash is, but essentially what this transaction hash does is kind of include all of this message data. What I mean by that is that if we were to change any information about this transaction, so let's say we change an input or we change what one of the outputs are, then the hash for this message is going to be completely different. This transaction hash is no longer going to be associated with the new message data because we just know as a property of a hash function, when we run something in, if we change any bit of that data, we get a completely different hash. So just keep that in mind. The transaction hash is essentially encoding the message of our transaction. Okay, so now that we have the transaction hash, what we need to do is generate a digital signature for it. Now, when we talk about digital signatures, we have two aspects. We have what's referred to as our signing key, which we can say is SK. We have our verification key, which is VK. Now, our signing key is simply our private key, okay? And that would make our verification key our public key. So we have our signing key and we have our verification key. Now, the signing key is what we use to sign the transaction hash, which is really just signing the transaction. And then we use our verification key or our public key to decrypt this signature and determine the transaction hash that's associated with it. So you'll see what I mean as I go through here, but just understand we have SK, we have VK. SK is our private key and VK is our public key. So what we do here is we take our signing key, again, which is our private key. We also take our transaction hash, so TX hash like that, and we pass this through some type of signing function. Now, this signing function is really just an encryption function. And what it does is take these two pieces of data and essentially encrypts the transaction hash with our private key, which is our signing key. Now, this is going to give us some type of signature, which I'll just denote with SIG. So now that we have this signature, we submit this signature along with the transaction data to the blockchain network or to the transaction pool. Assuming that our fee is high enough, this transaction gets picked up by a miner and they attempt to add it to a block. Now, while they're doing that, they're going to verify that the transaction is valid by using the signature. Now, the way that that actually works is they take all of the message data associated with the transaction and they themselves are going to hash that. So they're now going to have a transaction hash. So now that they have a transaction hash, what they're going to do is they're going to take the verification key, which is the public key of our account, which they'll know the public key, and they're going to take the signature, and they're going to run this through some verification function. And essentially what the verification function does is it decrypts this signature. So this is going to spit out a TX hash, and I'll just call this TX hash 2. Now, this transaction hash should be whatever the transaction hash is of this message. Now, I know this seems a bit confusing because we have a bunch of similar words kind of all over the page here, but just running through the process one more time, we take our message data, we hash it. That gives us a transaction hash. We then take our signing key, which is our private key, and our transaction hash, and we encrypt the hash of the transaction with the signing key. That is our signature. The encrypted transaction hash is the signature. We then, or what the miners will do, is they will take our verification key, which is our public key, and the signature that we've submitted alongside our transaction, and they will decrypt the signature using the verification key. Now, that's going to give them whatever the transaction hash is that was associated with our signature that we submitted. They're then going to verify that the transaction hash of our message data matches the hash that they got from this decryption function. And if that's the case, that means that the signature that we submitted is correct for this transaction and it's valid. We are able to actually submit the transaction onto the blockchain network. So hopefully that makes sense, but that is how a digital signature works. We're decrypting a transaction hash with our private key. We then use our public key to verify that that signature was indeed signed with the private key and to get a transaction hash. Now, this transaction hash is whatever would have been signed with the private key. So we then need to verify that the transaction hashes match. So the hash of the message data that we're trying to send, which is really just the transaction, needs to be the same as whatever the hash is that's spit out by the verification or decryption function. If that's the case, again, it's valid. We can send the transaction and all is good to go. Now, I'm not going to talk about how our signing function and our verification function work because those are pretty complicated, but just to go through, again, kind of the security here, since this message is being hashed into this transaction hash, if we change any aspect of this message, it completely changes the transaction hash. So if I try to sign something, so let's say I sign some message here, right? And then later on, this message gets changed. So we change whatever the outputs are to this transaction, then the signature that I generated for the old message will not match the transaction that we are trying to send to the network. So let's say what happens is I take my message, I hash it, I get my transaction hash. I then generate a signature. Let's call this signature 1. This signature is only valid for the transaction that contains the data that I signed it for. If I go and I change any aspect of this message, right, so we add different outputs, all of a sudden, the transaction hash here will be completely different. So that means if I try to submit a fraudulent message with, say, an old signature that I generated, what happens is this transaction hash output from the verification function is going to be different, and it's not going to allow me to submit the transaction because the signature is not valid. The signature is only valid for each individual transaction. If I make another transaction, I need to generate a new, completely different signature. And if I change any aspect of the transaction, say I'm trying to do some fraudulent stuff here, then again, the signature is not valid because it only works for the transaction hash, which includes all of the data with the original transaction. Again, I know that's a mouthful. It's a lot of stuff to explain and to understand at once, but that is how digital signatures work. Now that we've done that, I'm just going to clear the screen. We're going to go through a quick summary of everything, and then we'll wrap up the video. Okay, so time for the summary. When we create a transaction, we need to specify who we are sending this to. So we have our to, we have our amount, we have our fee or our gas, and then we have the change that we're going to be receiving back. We then need to specify as inputs to the transaction a bunch of other transactions, or at least one transaction, where all of the sums of the received amounts to our account or to our address equal how much we are sending here. So the amount, the fee, and the gas need to be equal to the amounts that are included in all of the transactions that we feed as inputs to the transaction. I know it seems a bit weird, but transaction is feeding a transaction. Now, again, by having these inputs as a part of the transaction, it gives us an entire history of where all funds have ever transferred or been moved across the blockchain network, because now this transaction is associated with previous transactions. So kind of an interesting fact there. Anyways, once we generate this transaction here, we take all of the data and we put this into what we call a message. Now, really, the message is just all of the data associated with the transaction. We then hash this message. So I'll actually put this into f of x, and this gives us the tx hash. Now that we have the hash of the transaction, we create a signature for this transaction hash. The way we do that is by using our signing key. Now, our signing key is our private key. So we take our signing key, we take our tx hash, we pass this to a signing algorithm or to a signing function, whatever you want to call it. So let's call it s of x, and let me just fix my broken arrow here. And then this outputs our signature. Now, this signature is specific for this transaction and for all of the data associated with that transaction. If you change any of the data, then this signature is no longer valid for it. So this signature we take and we submit that alongside our message or alongside our transaction data, and that gets added to the transaction pool. Now, once our transaction is in the pool, miners will pick that up and they will verify that the signature is correct and for this message or for this transaction. The way they do that is they take our verification key, which is our public key, and they take the signature and they decrypt it. So they run it through this verification algorithm or verification function, and this spits out the hash that is associated with the signature that we created. So we're encrypting the transaction hash with our private key, and we are then decrypting the signature with our public key, which is our verification key. Now, if this transaction hash matches the hash of all of the transaction data that was submitted to the blockchain, then that means that this is valid. We go ahead and we submit or we add the transaction to the blockchain. And again, we're going to talk about how that works in future videos. So I do apologize for the long video here, but I wanted to make sure everything was crystal clear and walk you through all of the specific details related to a transaction. With that said, though, I will wrap up the video here. I hope you found this helpful, and I look forward to seeing you in another Blockchain Expert video.